Good morning, Pharma Excipients community. Today we have two guests from Fuji Chemical, Mark Blanket, Technical Marketing Manager, and Bhavesh Patel, Technical Service Manager. We are talking about Fuji solutions and tips for the best oil adsorptions. So if you're having trouble formulating an oily API, this is an interview you need to watch. And as always, don't hesitate to contact us if you have more questions or need a sample. Mark, Bhavesh, thank you for being here with me today.
Thanks, Tom.
Thank you. Thank you, Tom.
You're welcome. And now let's start with the first question. Bhavesh, why is oil adsorption such an important topic in the excipients industry?
Well, it is an important topic because not all the components of solid dosage forms are free-flowing and simple to formulate. Many additives and API are liquid in form, some are in sticky nature, and these have adverse impact on the flowability of powder. They also affect the compressibility as well as the tabletability issue. So there are importance of to convert this oily API into free-flowing powder form, and it improves the performance of tablet and the finished solid dosage form.
Can you give some examples of oily components you may want to put in tablets and powders?
Sure, Tom. For example, in nutraceutical, we have active components such as essential oils like omega-3, some of the APIs such as fish oil, krill oil, astaxanthin. So these are in oily form under nutraceutical. And in pharmaceutical also, there are few API such as simethicone oil, vitamin D3, tocopherol, some of the solubilizer such as polysorbate 80, hydrogenated castor oils. So these are the list of some of the API which are in oily form, and that can be adsorbed on some of the excipient to compress into tablet and capsule.
That sounds very reasonable, and it is a perfect transition to my next question. Because Fuji has a lot of excipients, and which of them can I use for oil adsorption?
Yeah, Tom, at Fuji, we produce all of our excipients by spray drying. And as part of this process, it's possible to create the internal porosity. And that has multiple uses, including oil absorption. And we do this with a number of our products. And that includes our Nusilin, Fuji Kaolin, and Fujisil.
All right, but you didn't mention Fmelt right now. Can I use it for oil adsorption? Or for what do I need exactly?
Yeah, Tom, I didn't mention Fmelt because it's really a different product. This is a co-processed excipient specifically designed for fast melting or fast disintegration. Typically, we use that in products like orally disintegrating tablets and chewable tablets. Strictly speaking, there is some porosity, but it's really not ideal for this purpose, especially when you have products like Fuji Kaolin and Nusilin, which are specifically designed for this. Of course, you can combine Fuji Kaolin and Nusilin and products like this with Fmelt, and then you can get the best of both worlds. So you get the oil absorption, and you can combine that with the fast disintegration and the smooth texture, the creamy mouthfeel, and so on that you get with the ODT type product like Fmelt. So we can get the best of both worlds.
Oh, good to know. That's why. And just now you mentioned the three product families, Nusilin, Fuji Kaolin, and Fujisil. But there are so many products in there. Is there any guidance you can give me?
Yes. In fact, there are various factors need to be considered, such as porosity, specific surface area, chemical compatibility, some of the regulatory aspect, and the end applications. As an example, if you are working with pharmaceutical uses, then you can go with Nusilin, which is much higher surface area. And for porosity point of view, Nusilin would be the better option. If you are working with nutraceutical, then you can go with Fuji Kaolin. Apart from that, it also recommended to check the chemical compatibility, and you can optimize based on the situation.
That helps for sure. Thank you. Mark, what would you say are the key features of these excipients? Are there differences in use or in characteristics?
That's a great question, Tom. I'd like to focus on three aspects here, which are key for Fuji excipients. The first is good flowability. So we have these spray-dried granules. They're around 100 micron in size. They have this sort of rough, non-sticky surface, So these things are naturally designed for good flowability. So we have an angle of repose typically around 30 degrees. So they're great for that application. The second real key aspect here is the high porosity. Different products have different porosity, but they all have are designed to have a high porosity, and that means we can load a lot of oil. Also, if you compress these materials into a tablet, of course you reduce that internal porosity, but because you're maintaining around 30% and still forming nice tablets, that means that we can still have high loadings of oil in a compressed form as well. So both the pre and post compression can be important depending on the application. And the third one, which I sort of hinted on, is the superior tabletability that you get with the Fuji excipients. So being able to form nice hard tablets that have low friability, high quality, and that maintain that oil concentration. So we can have 30% oil in a nice, hard, good quality tablet, and that's absolutely key.
Wow, impressive. Thank you, Mark. Bhavesh, I saw in the brochure that some of your excipients loading more oil and some less. Which excipient would you recommend the most? And is loading of more oil only positive, or does it come with any restrictions in another area?
Interesting question, Tom. In fact, loading of more oily API is not sufficient. You need to consider various other factors, such as chemical compatibility of API with mucilin and fujicalin. You have to also check the in vitro drug release rate, which is also known as the desorption rate, how fast your oil gets dissolved from the surface of your excipient, that you can check by in vitro dissolution test. You have to also consider the compressibility of powder after oil adsorption, and there should be no any oil leaking issue during compression into tablet form. So these are the all factors apart from loading of more oil. This factor you have to consider.
I understand. And now I have a smaller question, but I'm curious. How exactly is the oil absorbed, and what have capillary force to do with that?
Tom, this is like a capillary force, and it is basically a wetting-driven phenomena. These particles are like a little sponge. If you put a sponge onto the top of water, then it sucks the water into the pores of a sponge, and it is basically a capillary force.
Ah, that's easy to understand. And that's leading directly to my next question. I hear that sometimes the surface of the excipient is oily after the adsorption. Does this also apply at Fuji excipients?
Typically, no, Tom. If it is, you're doing something wrong. Fuji excipients really excel here, but there's two main things to remember. The first one is that this is a dynamic event. It takes time for an oil to absorb in. So sometimes you need to give the oil time to absorb in, and that comes down to viscosity. If your viscosity is too high, that may mean that the dynamics are very slow, which can lead to a problem. If that's the case and you need to speed it up, of course you can reduce the viscosity. Temperature or solvents will solve that. And the second is don't overload.
Thanks, Mark. Good to know. But now I'm going in a little different direction or area, like with which pressure can I press a tablet?
Sure, Tom. Here I would like to say that key aspect is the tablet hardness, since compression pressure usually varies with respect to different systems. So let me give you at least two examples. In general, we suggest compression of tablet at lower range of 40 Newton hardness and higher range of 50 Newton hardness to achieve the better functionality of tablet with minimum oil losing from the tablet surface.
Thanks a lot, Bhavesh. And now last, but for sure not least, what are the benefits of your product in comparison with competitors?
Yeah, Tom. Fuji products are specifically designed for oil absorption. That's really the key aspect here. And it comes down to a number of different reasons for that. The first one is our products have good flowability. The spray dry process that we talked about earlier means we have good flowability, and that's critical for manufacturing and product use. The second is the high porosity. Because we have high porosity in our products, they're good. They're good for using in oil absorption. And that's both pre and post compression, as I talked about earlier. The third point I'd like to raise is good tabletability. We've got to be able to make hard, high quality tablets And these excipients are specifically engineered to do that. The next point that we want to talk about is regulatory, and Bhavesh introduced that a little bit earlier. We've got to be able to have the right regulatory compliance for the product. The fifth point was also raised by Bhavesh, which is the absorption and release rates. And here, being able to optimize the interaction between the particular component and the excipient in question is really, really key. And having multiple chemistry options is really key. And that's something that we've focused on in terms of being able to do this. So in summary, we have a range of products specifically designed for oil absorption, and these products can all give high quality end products for you as our customers.
Thanks a lot for the answer, Mark. Thanks for this exciting interview, you two. I learned a lot of interesting facts today, and I hope our users too. Bhavesh, Mark, thanks again for your time.
Thank you very much, Tom.
Thank you, Tom.
You're welcome, and have a good day. Bye-bye.